Hello everyone, welcome to the next lecture on the PY question series. Today, based on your request, I will upload the next lecture on the calculus of variation. This is the part 1 on this topic. Myself, Dr. Harish Garg. You can find me on the YouTube channel where you can find the playlist of CSIR UGC, NET and GATE. In this playlist, you can find the various lectures related to the PY question series. All these lectures are explained with the help of the shortcut. I hope you can subscribe my YouTube channel so that when I upload my next video, you will get the notification. So as I explained you in my previous lectures, before I directly jump to the PY question series, let me give you some tips so that you can solve each question with the help of the 10 to 15 second time. Make sure student, this is the part 1 on the calculus of variation. After this video, I will upload the part 2 if I get the good likes and the comment on this video. If I didn't get a good support from each of you, then I hope this will be my last video again for you on the calculus of variation. If you really want to get some more videos from my side, you need to support me by like, comment and share this video with your friends. Now, in each year related to the CSIR NET examination, or you can say about the GATE examination, every year this calculus of variation question definitely asked in the examination. If we talk about the calculus of talk about the CSIR NET examination, one question from the part B, which is of the 3 marks, and one question from the part C, that is a 4.75 marks. At least 2 questions will be asked in the CSIR NET examination on this topic. So you can get a 7.75 marks in a very simple manner. If you watch this video till the end, you will learn how you can get these 7.75 marks within the 10 to 15 second time. Fine. So let's start with this video. I hope you can watch till the end so that you can learn many shortcut tricks. Whenever there is a question related to the calculus of variation in your examination, make sure you need to find this initial condition as well. Fine. Say I call as a alpha and this is beta. Whenever you will see the calculus of variation, then the first step is always to find the solution. How you can find the solution? You have to start with the Euler equation. This is my Euler equation. After solving this equation, you will get the value of the y, and that value of y is called as the extremal. This is the first method. But make sure this is the tips when function is dependent on the x, y and y dash. But if your function is dependent upon the higher derivative as well, then you have to add the additional term which is defined as second derivative of this. If your function involvement of the third derivative also, then instead of this you can write as a plus minus third derivative with respect to x into partial derivative of y f with respect to the third derivative. If your function involvement of the fourth derivative, then plus minus and so on, you can write this equation as. So these equations are called as the Euler equation. Second important concept, whenever your function is independent of the x and y both, then there is no need to write this equation. You can write the solution directly as y is equal to ax plus b, or you can write the solution as a plus bx. Third shortcut trick is whenever the function is independent of x only, fine, it's only x. In this case, it is independent of both. If your function is independent of x only, then you can write the solution in this manner. Make sure either you can start this equation by this equation or by this. That's on your choice. For example, I will tell you under what case you can use this equation number 1 or under what case you can use equation number 2. For example, your function of the f will be by this case, y dash square, or your function of the y f will be y into y dash, or y into y dash divided by 1 plus y square. Whenever there is a term involvement of the plus or minus, you can always use the equation number 1. Whenever there is a term involvement of the multiply or divide, then you can always use the equation number 2. Fine. You may use the equation number 1 or 2 for the both case, but I will tell you the suggestion that whenever there is an involvement of the plus or minus term, then you can use the equation number 1 for the easy calculation, while the equation number 2 when there is a product sign. If I say my equation is only y into y dash. Since it's a product sign, so I can use the equation number 2. But if my equation is like this manner, now since it's the plus sign, so I have to use equation number 1. In Hindi, अगर आपके पास कोई ऐसा फंक्शन है जो इंडिपेंडेंट ऑफ x हो, और कब आपको इक्वेशन नंबर 1 यूज करनी है और कब आपको इक्वेशन नंबर 2 यूज करनी है, अगर आपके पास फंक्शन ऑफ f प्लस और माइनस की फॉर्म में है तो आप हमेशा इक्वेशन नंबर 1 यूज करिए, आपका आंसर जल्दी आएगा. और अगर वो आपका आंसर प्रोडक्ट में है या डिवीजन में है तो आप इक्वेशन नंबर 2 का यूज करिए. Before watching this lecture, I recommended you must watch about my this lecture, that is the boundary value problem. I will use these shortcut tricks that I explained in this lecture frequently in this video. This lecture you can find at my YouTube channel. If you are new to my YouTube video, you can scan and join my WhatsApp group for the easiness. I hope you can share, you can like and comment on my video. Now, you can see this function is my independent of x. But because of this plus sign, I can use this formula. Find partial derivative into f upon y dash is equal to 0. In your examination, there is no need to write this on your copy. You can write this equation in your mind. Because I have to explain each thing for you, that's why I have written this question in this equation in your board. What is the partial derivative with respect to f by minus? This value is again 1, this is 0. So what is the answer of this? 1 minus 0 is equal to 0, which is not possible. 1 is not 0. That means no extremal. Right answer is A is my correct answer. Look at the second case. Whenever there is a question related to the initial condition, always apply this initial condition in this given option. Is it satisfied? Yes. Is it satisfied? Yes. Y of 0, 1, y of 0, 1. Satisfied. Now you can see whatever the answer of this, what is the value of the y1? Is my constant. Fine. So this number will be my constant. So therefore your capital F is my only y dash square, and clearly say this is my independent of x and y. Once this is my independent of x and y, what will be my solution? Solution is ax plus b. Now look at the option. The last one is the x square. Option cancel. First one x square, option cancel. Fine. Now how you can check about the first, second and the third. So let's start with the second option. I can substitute this value in the given statement and we will see which one is the minimum. What is the value of the j? What is the value of the y1? Half. Half square is 1 over 4 plus integration. What is the value of the y dash? Y dash is minus half. If you substitute them, it's a plus 1 by 4. So what is the integration of this? It's a 1 over 4 plus 1 over 4. That is a 0.5. Look at the third option. What is the value of the y1? Y1 is 3 by 4. 3 by 2. So the square will be 9 by 4. What is the derivative is 1 over 2. So what is the answer of this? It's a 9 over 4 plus 1 over 4. That's a 10 over 4. Answer is 2.5. So clearly say this term is my minimum. So the right answer is B is my correct option of this problem. Look at this another one. Again, this is a function of the x and y as well as y dash. I can start with this equation. So I can substitute the values. What is the y? It's a 2y minus 2 sine x minus partial derivative del f upon del y is a 2y dash is equal to 0. I can cancel that 2, then y minus sine x minus y double dash is equal to 0, or I can write as y double dash minus y is equal to minus sine x. Now clearly say this is a simple ordinary differential equation. Once is a simple ordinary differential equation, can you find this solution? The auxiliary equation is m square minus 1. The solution will be c1 e raised to power x, c2 e raised to power minus x. The first option is cancelled because of e raised to power 2x. Last option is also cancelled. Can you find the particular integral? The particular integral is 1 over d square minus 1 into minus sine x. So now I can substitute this value. What is the d square is? You all know it's a minus of a square. it is a minus 1 into minus 1 is minus of 2 into sine x. The answer will be half sine x. It's a positive half, but he said it's negative. So this option is cancelled. The left option B is my right. Again, this extremal is given to you. Now again you can see the options are given, the initial conditions are given. Check whether satisfied. Yes. Y of 1 is not 1. This equation not satisfied. Y of 1 not 1. Y of 1 not 1. So the left option A is my correct answer of this problem. You can see within a fraction of a second you can solve each problem in a simple manner. Don't forget to support my efforts by liking and commenting on the video. Now again the extremal is given to you. Y of 1 is equal to 1. Firstly we can see whether satisfied. Yes, it is also satisfied. This is not satisfied. This is not satisfied. Your first step is always, whenever the condition is given to you, substitute in the given option. Y of 2 is arbitrary. What is the meaning of the arbitrary? We can apply the free boundary condition. What is the meaning of the free boundary condition? Del f upon del y dash is 0 at the point of x is equal to 2. So can you find the value of the del f upon del y? This is my, it is my 2y dash plus 2y is equal to 0 at the point x is equal to 2. That means y dash of 2 plus y of 2 is my 0. Fine. This is my second condition. This is my first condition. Now look at the option. What is the y dash? This is my y dash at the point 2. If I look about the first option, what is the y dash at the point 2? It's a e raised to power 1 plus what is the y of 2? E raised to power 1, which is not 0. So this option is cancelled. Only left option is C is my correct answer. How we can see what is the y dash? Y dash is minus e raised to power 1 minus x. So what is the value of the y dash of 2? Y dash over 2 is e raised to power minus 1. What is the y of 2? Is the e raised to power minus 1. If you add them, it will be 0. So the right answer is C is my correct answer. This is the way you can solve it in a very simple manner. Otherwise, you can also solve it based on the given condition. I can start with this value. This is a second method, but that is quite lengthy. But if you want to solve this, you can also adopt that. What is the value of the del f upon del y? It is my 2y dash plus 2y minus, what is the y dash? Is a 2y dash plus 2y is equal to 0. So I can take 2 as a common, it will be cancelled out, minus y double dash minus y dash is 0. That means y double dash minus y is equal to 0. So that means y will be my auxiliary equation is m square minus 1 is 0. So e raised to power x plus c2 e raised to power minus x. Fine. I can substitute this value, apply these two conditions. What is the y dash? Add the 2 e raised to power 2 minus c2 e raised to power minus 2 plus c1 e raised to power 2 plus c2 e raised to power minus 2 is 0. So clearly say from this case c1 will be 0. Once c1 will be 0, your solution will be in the terms of e raised to power minus x. So clearly say this is the only term which is my minus. I can find the value of the c2 based on y of 1 is 1. But the first method is quite easy. You can use the options and get your right answer. Okay. First of all, I will give you the tips. Whenever there is a question related to the infimum or supremum, fine, you always need to, how you can check about the infimum of supremum? You always need to check about this condition. If this condition is my greater than 0 at the extremal point, fine, extremal means at the value of the y, then we can say this is my minimum or infimum. If this point is my less than 0, then we can say this is my max. Fine. Whenever there is a question related to the infimum, supremum and so on. Now, so firstly your target is to find the extremal. These are my two conditions given. Look at that. What is my f? E raised to power minus u dash square. So clearly say this function is my independent of x and y. Now instead of the y, it is my x and u. So what will be my solution? U is my ax plus b. Apply this condition. U of 0 is my 0. What does it mean? B is equal to 0. U of 1 is equal to 0. That means a is equal to 0. So therefore your extremal will be 0. Fine. Now once you know this is extremal, now you can check whether it's a minimum or maximum occur or not. You can start with this value del square f upon u dash square. Fine. So how you can find that? Let me firstly find the first derivative. The first derivative will be minus 2u dash e raised to power minus u dash square. Can you find the second derivative with respect to u dash square? I can apply the product rule. U dash square minus minus plus 4 u dash square e raised to power minus. Now at this point, if u is equal to 0, u dash also 0. What is the value of this? Minus of 2 less than 0. That means minimum value. So that means infimum. That's a less than 0. That's a maximum value. So what is the maximum value of this? Can you find the value of the j? U dash is 0. That means e raised to power. So the answer is this is my maximum value. Now since this will give you the only, because the extremal is my unique, it give only the maximum value. That means no minimum value. That means no infimum exists. So it does not attain the minimum value. That's the infimum is the right. Look at this another one. Consider the function. Again you can see this function is my independent of x and y. So my solution will be y is equal to ax plus b. Apply the initial condition. Y of 0 is 0. That means b is equal to 0. Y of 2 is equal to 0. That means a is equal to 0. So my solution will be y of x is 0. So y of x 0 is my unique solution. So the right answer is A is my correct answer. Don't forget to like and comment on my video. Now the conditions are given to you and your target is to find the phi of this. What is my f? Y square, y dash square. So clearly say this is my independent of x, and also it is written in the form of the product. So my Euler equation will be f minus y dash del f upon del y dash is equal to constant. So I can substitute the value of the y square, y double dash into 2 times y square, y dash is equal to constant. So what is the value of this? It's a twice. I can say it's a minus y square, y dash square is equal to constant. I can take a minus on the right hand side, another constant, put them as a square root, again a constant. This is called as the a. Fine. So then I can write this number is dy over dx, this quantity. Then I can integrate them. It's a y square over 2. It's a 2 times a plus constant b. Fine. Clear? Then apply the initial condition. Y of 0 is 0. That means b is my 0. Y of 1 is equal to 1. That means a is equal to half. So your solution will be y square is equal to x. So y will be root x plus minus. Fine. Now y is equal to my phi x and your target is to find the value of 1 by 4. So the answer will be 1 by 4 of root. A is my right answer of this problem. Look at this another one. Again this is my f. Firstly you can check about y of 0 satisfied. Yes. This is satisfied. Satisfied. Y of 1 is satisfied. 11 plus 1 12. 6 plus 1 7. 2 plus 1 3. All are satisfied. Then I can start with this condition. Partial derivative of f with respect to y dash is equal to 0. As I told you in your examination, there is no need to write this. You can write this equation in your mind. Del f upon del y x minus partial derivative with respect to y dash 4 y dash is equal to 0. So what is the meaning of that? 4 times y double dash is equal to x. That means y double dash will be my x over 4. So what does it mean? Now there is no need to solve. Look at that. The second derivative is my linear equation. Then what will be the degree of the y? It will be my cubic. Then only the second derivative will be my linear equation. So y, degree of y will be cubic. It's a square, cancel. It's a square, cancel. Fine. Now we can look about the option. If I check about the second option, what is the second derivative of this case? The first derivative will be 3x square over 3 plus 4x over 3. Second derivative will be my 2x plus 4 over 3. Clearly say which is not equal to x over 4. So this option is cancelled. The only left option is D is my right answer. I will check also for you what is the second derivative. First derivative will be 3x square upon 24 plus 23 over 24. Second derivative will be 6x over 24 plus 0. So clearly say this is my x over 4. So the right answer is D is my correct answer. Always remember student, there is no need to integrate them. Always solve partially with respect to here and look at the options. The Euler equation of the extremal. Again, what is the partial derivative with respect to y? Minus partial derivative of f with respect to y dash. What is the partial derivative of f with respect to y? Is 2y minus partial derivative of this is my x cube. So what is the right answer of this? 2y minus 3x square is 0. That means extremal will be 3 over 2x square. It is a parabola. So once it's a parabola, that means it is my quadratic equation. You can see within the 10 to 15 seconds you can get your answers always. Okay, which of the following is my solution? Now 1 plus y square, clearly say this function is my independent of x, and also this is written the product form. So I can start with this expression. Del f upon del y dash is equal to constant. I can substitute the value of the f. 1 plus y square upon y dash square minus y dash. What is the derivative of this? Minus 2 upon y dash cube into 1 plus y square is equal to constant. You can see one value will be cancelled out. Y dash square will be the LCM. 2 plus 1 is 3. 1 plus y square upon y dash square is c. I can take c over 3 as another constant. I called 1 plus y square is constant d into y dash square, or y dash over 1 plus y square is another constant called as the d. Fine. Now look at the option. If you take the first option is a sin x. What is the y dash is? A cos x divided by 1 plus a square sin square. Is it a constant? No. Similarly, this is not a constant. Fine. Or you can integrate them. If you integrate the left hand side, what will happen? This is my sine hyperbolic y. The right hand side will be dx plus e. So what is the value of the y? Y is my sine hyperbolic dx plus e is the right answer of this problem. So C is the correct answer of this problem. Okay, look at this another one. The extremal is given to be there. You can see this function is independent of x and y because this is the modulus value and it's a square. So I can write this function is only, because square is always, it is independent of x and y. What will be my solution? Solution will be y is equal to ax plus b. Now look at the option. Does not exist, cancel. Y double dash 0, satisfied. Is a straight line which passing through a comma ya, b comma yb, satisfied. Now look at this option. Second is the solution of the differential equation. If this is the solution of the differential equation, it means this will satisfy this equation. So what is the left hand side is a, right hand side is c is my any constant into 1 plus y dash is a square. So clearly say if you square them, it's a c square 1 plus a square. That means a, this is a constant, a, b are constant, this is my constant, both are my constant. So I can particularly choose the constant c for some constant so that these two equations are same. Yes, because you can see this number is my over 1 minus c square. So that means this equation is satisfied. So therefore, this option is also correct. Right answers are A, B, C are my right. Because this is for some c. If I choose A is my say 4, then I can easily choose the value of the c so that this number is also 4. So the right answer is A, B, C are the correct answer. Now, look at the another options. Again, the initial condition is given to you. Firstly, we can check whether it is satisfied. Yes, it is also satisfied. Why cos 0 it is not satisfied. Cos 0 it is not satisfied. Always remember student, whenever the initial condition given, you have to substitute firstly in the given expression. Your target is to find the value of this. But there is one additional condition given to you. Fine. So whenever there is some additional condition given to you, you have to define the value of the f firstly by using the given extremal minus lambda times of this value. Fine. Now clearly say this is my independent of the x, but because of the plus minus sign, I can start with this equation minus partial derivative of del f upon del y dash is constant 0. So what is that? Del f upon del y minus 2 lambda y minus partial derivative is 2y dash is equal to 0. I can take 2 as a common, it's a cancel out. Y double dash plus lambda y is equal to 0. Fine. Now, what come in your mind whenever you will see this equation and expression is this value? Do you get anything? How you can solve that? Can you write the solution directly? Definitely you can write if you have watched my this lecture. This is a Sturm-Liouville problem. I already explained you how you can find the value of lambda. Lambda is my n pi over L whole square, and the solution will be my a sine of root lambda into x. What is the L? L will be my this limit of b minus a, because the limit is 0 to pi, so the value of this is my pi. So can you find the value of lambda? L is my pi, so it's cancel out, it's a n square. Now look at the option, it's a 1. So I can choose value of the n is my 1. Fine. If n is equal to 1, then lambda will be 1. So therefore, y is my a sine x. Fine. Then the only target is what is the value of the a. So now how you can find the value of a? Again a very simple, what is the given condition? Double, that is the integration y square, that means a square sine square x of dx is my 1. I can solve this. I can use the orthogonal property. What is the orthogonal property of the sine square x? That is pi over 2, which is 1. What is the value of the a? A is my plus minus 2 over root pi. So its the answer is A and B both are the right. You must watch about my this lecture before this today's lecture. Fine, so that you can learn the trick in a very simple manner. Don't forget to like and comment on the video. Remember student, I will upload the next lecture based on only your likes and comments. Otherwise this will be the, I hope so, this will be the last video on this CSIR net topic. Okay, the next one is the functional given to be here. The points are, okay, what is the weak minima, weak maxima? First of all, whenever you are talking about the weak minima and the weak maxima, you have to start from this case. If this is greater than 0 for all those values of the y, then we call as the strong minima. If this is greater than 0 for some value of the y, fine, then we will call as the weak minima. On the other hand, if this is less than equal to 0 for all those values of the y, then we call as the strong maxima. And if this is less than 0 for some value of the y, then we call as the weak maxima. Fine. Also, strong maxima or minima implies weak maxima and minima, but converse need not be true. Now, what is the value of the y? y is my extremal. So your first target is to find the extremal. It is already given to you that this is my extremal because this is also satisfy the given condition. So my target is, this is my f. Your target is to find only double derivative. So what is the first derivative? What is the first derivative? 2y dash. Second derivative is 2, which is greater than 0 for all those values of the y. So that means this is my minima. Minima means that's a strong minima. So that's a strong minima is the right maxima cancel. Every strong minima is also called as the weak minima. So weak minima is right. This option is cancelled. A and C are the right answer of this problem. Make sure, student, if remember, if this condition is not given to you, for example, this condition is not given to you, then as usual you can start with this case, minus del f upon del y is equal to 0. Then you can find this equation. What is the del f upon 0 into del f upon del y dash is a 2y dash is equal to 0. That means y double dash is equal to 0. Y double dash 0 means y is equal to ax plus b is my solution. After finding this, substitute this value. Y of 0 is equal to 0. Sorry, y of 0 is equal to minus 1. This implies b is equal to minus 1. Y of 1 is equal to 1. This implies a is equal to 2. And you can see the same condition is obtained. In this case, it is already given to you, so there is no need to solve this case. So the right answers are A and C are the correct option. Okay, look at this one. Y is a piecewise continuous differentiable function of this case such that attain the minimum value. Clearly say this function is my independent of x and y. So my solution will be y is equal to ax plus b. So look at the option which is not ax plus b. All are my ax plus b. My target is to find the values at the minimum. Very simple. Very simple. I can look at the options. When y is equal to x by 2, what is the value of the j? I can substitute this value. What is the y dash? Half. Half minus 1. Half. Half square is 1 over 4. Half plus 1, 3 over 2. That is a 9 over 4. So what is the integration of this is? 9 over 4. Look at the second part. J. So since it is a discontinuous function, so I can break them from the 0 to 1 and then 1 to 4. What is the value from the 0 to 1? The function is minus x. What is the y dash? Minus 1. It's a minus 1, minus 1, minus 2, 4. This number is 4, but this number is 0. 4 into 0 is 0. And this part is plus 1. This part is 0. So the answer is 0. Third case. Again, it breaks from the 0 to 2 and then 2 to 4. First derivative is 2. So it's my 2. 2 minus 1 is 1 into when 2, this number is my 2 minus 1 square and 2 plus 1 square, 3, 9, 9 into 1 is, so this is my 9, 2 to 4, that's a minus 1, is a minus 1, is 0. So the right answer is integration of this is my 18. Look at the last case, it break from 3 to 0 and 3 to 4. It's a plus 1, derivative will be 0. It is minus 1, derivative is minus 2, it's a 0. So answer is 0. Now look at that, which one is the minimum? 9 by 4, 0, 18, 0. So this and this both are my minimum. So second and the fourth options are the correct option of this problem. Because at this point we will get the minimum value. If they are asking about the maximum value, then your answer will be third option is the maximum. Okay, look at that. Only one condition is given to you, but we need at least two conditions. Fine. So since only one condition is given to you at the point of initial, the second condition will be my free condition. That means del f upon is my u dash is 0 at x is equal to 1 because the second point is my 1. Fine. Now What is my f? This is u dash square minus u square. Clearly say this is my independent of x. Now also they are talking about the bounded below infimum. Infimum. What is the shortcut tricks? As I told you, whenever there is a question of the infimum and the supremum, you need to find the values of this case, whether it's a less than 0 or greater than 0 at the extremal. So that means you have to find the firstly the value of the y. Now it is independent of y and it's a negative sign, so I can start with this case. Now in this case, instead of the y, what is that? It's a u. I can write this is my u, or del f upon del u minus del f upon y dash. Y dash means that's a u dash is 0. So substitute this value is a minus of 2u minus of 2u dash is equal to 0. I can minus of 2, I can divide them. It's a u double dash plus u is equal to 0. Fine. So clearly say the solution will be, because u of 0 is 0, the only solution will be my sin x. Cos will not be satisfied. A sin x will be my solution. Otherwise, again you can use as a boundary value problem. So the lambda will be n pi upon L. Fine. And the solution will be y is equal to a sine root lambda times x. That's again same. Now you got as a u. Now you can find the second derivative. We will see whether is an infimum exists or not. What is the first derivative with respect to u dash? It's a 2u dash. What is the second derivative? Second derivative will be my plus of 2, which is greater than 0. That means the minimum occurs. So minimum occur means infimum occurs. So does not attain. Now what is the minimum value? I can find the values at the I. I can substitute this value u in this case. So it's a 0 to 1. What is the u? No. What is the a? I have to apply this condition also, because I need to find the value of the u. Can you find the value of the arbitrary constant a? Now since del f upon del u dash, that means 2u dash is equal to 0 at x is equal to 1. So I can substitute this value, twice of u dash, 2 times cos x is equal to 0 at x is equal to 1. So at x is equal to 1, cos 1 can never be 0. That means a is equal to 0. So therefore your solution is 0. Fine. Now we can check about that. What is the second derivative of u dash square, which is 2 greater than 0? That means minimum. Now what is the value of the minimum? I can substitute this value 0. U dash is also 0, because if u is equal to 0, u dash also 0. Answer is 0. Now since it is a minimum, so that means yes, minimum occur, because it's a closed interval. So yes, it's a bounded below, because it's a minimum value. So the minimum value of this is my greater than equal to 0, and the minimum occur at the, so I also attained. These two options cancel. A and C are the right. Okay, look at this. Again, the initial conditions are given to you. Fine. So this is y of 0. So firstly we can check about the option y0 satisfied, y of 1, 2 plus 1, 3 satisfied, 4 plus 4 satisfied, 1 plus 1 satisfied, 4 plus 5, 5 minus 6 not 0, y dash 0. So out of these three options, definitely the y dash 0 is 0. Y dash of 1 is a 1. Y dash of 1 is 6 or not? So it's a 6 plus 6 minus 6. It is a 6, fine. It is 5 plus 16 minus 15. Again satisfied. This is 5 plus 4 minus 6. Is it a 6? 10 minus 6, 4. This is not satisfied. Now, out of these two options, which one is the correct? Now I can start. Now this is the second derivative. So what is the del f minus partial derivative f upon y dash plus second derivative plus minus del f upon y double dash is equal to 0. Now substitute the value. This will be 720x square. There is no y dash, 0. Second derivative of the y double dash minus 2y double dash. I can take 2 as a common, cancel out. 360 x square minus y of fourth derivative, 0. That means fourth derivative will be my 360 x square. Now, if the fourth derivative is my quadratic equation, what is the degree of the y? Degree of y will be my sixth degree. Fine. If the fourth derivative is x square, the y degree will be 6. You can see it's a fifth degree. Cancel out. Only left option is A is my right answer of this problem. If you start with this equation, then clearly say the second and the third option directly cancel out, and this equation is not satisfied my initial. Now again y of 0 is given to you. Again you can see some additional condition given. I can define the value of the is y dash square minus lambda times y square. Fine. Then I can start the equation with fine minus of del f upon del y dash is equal to 0. So let's start with this 2 lambda y minus of 2 y dash is equal to 0. So clearly say it will be y double dash plus lambda y is equal to 0. Fine. Your target is to find the minimum value of this. Your target is to find the value of I. Now also given that y of 0, y of pi is equal to 0. So that means it's a boundary value problem. So what is my solution? A sine under root lambda of x, where lambda will be n pi over L whole square. What is the L? L is my pi. Fine. The length of this. So that means lambda will be n square. So therefore the value of the y will be my A sine nx. Fine. Now I can, because n is my integer, so I can choose n is my particular value 1. Because in the option there is no given, so I can choose the particular value of 1. Fine. How you can find the value of A? I can use again this condition, 0 to pi sine square x of dx is 1. Again by using the orthogonal property, this is a square, pi over 2 is my 1. A will be plus minus 2 over root pi. Fine. Now your target is to find the value of I. So I can substitute this value. So what is the value of the y dash square? This is a square. This is my y. So a square cos square x of dx. Again use the orthogonal property, a square of pi over 2. What is the a square is? This. So this number is 1. So a, that is a b, is my right. Okay, the extremal of this equation is, again we will see firstly initial condition satisfied, x of 0, 1 satisfied, again satisfied, this satisfied, satisfied. Is the derivative 0 satisfied? Derivative 0 satisfied. This is not satisfied because the derivative is 2t plus 1. So this option is cancelled. This equation satisfied. Now what is my f? I can write this equation in terms of the x and y. T I can consider as a x and this as a y. This is y plus y dash square. Then by the Euler equation, partial derivative of f with respect to y, partial derivative of f with respect to y dash, 0. So that means alpha x is equal to 2 y double dash. Y double dash will be my alpha x by 2. So you can see y double dash is my linear equation. So that means y will be my cubic equation. Then only the second derivative will be my linear. So that means cubic equation. This fourth derivative cancel. Now out of these two options, we will see whose derivative will be alpha x by 2. Clearly say this option is cancelled out because there is no denominator part. Or you can take the second derivative. The first derivative will be 2 alpha t. Second derivative will be, and clearly say which is not equal to alpha x by 2. And if you take this second derivative, it will be my 6 alpha over 12 into t. So clearly say it's a alpha t by 2. So A is my right answer of this problem. Okay, look at this one. The value of the f is given to you y double dash square minus of 2y. Since it's a double dash, it's a f minus del f upon del y dash plus del square upon del x square into del f upon del y double dash is 0. Initial condition is given to you. We will see which one is not satisfied. Y of 0, y of 1, 0, 1, all are satisfied. Now since it is my second, fine. So I need 2 more conditions. It is given to you as the natural boundary condition. So what is that? Del f upon is my 0 at x is equal to 0 and at x is equal to 1. Now that's over. I can substitute this value. What is the del f upon minus 2? This number is 0. Second derivative of this number is twice y double dash is 0. So 2 will be cancelled out. So that means the fourth derivative will be my 1. Fine. Now if the fourth derivative will be 1, so what is the equation degree of the y? That is my fourth degree. Fine. So all are my fourth degree. So can you find the solution? So that means y is my a plus bx plus cx square plus dx cube plus x4 upon 24. Clear? Now look at the options. First of all, y of 0 is 0. That means a is my 0. Fine. Look at this. Okay, I will check about this case. What is the second derivative of this? The first derivative of this will be my b plus 2cx plus 3dx square plus x cube upon 6. This is my first derivative. Second derivative will be 2c plus 6 into dx plus x square over 2. This is my second derivative. Now what is given to you? Second derivative at the point x is equal to 0 is 0. That means 2c is my 0. The c means coefficient of the x square. So you can see in this case there is involvement of the x square coefficient. Cancel. In this case there is a constant part. Coefficient of the x square is 1 over 24, but we need a 0. There is no coefficient of the x square because it's x cube. There is no coefficient. At the point x is equal to 1, c is equal to 0. 6d plus half is equal to 0. That means d will be minus 1 over 12. D is my coefficient of the x cube. So you can see this is the coefficient of the x cube. It is not 1 over minus 1 over 12, but it is minus 1 over. So C is my right answer of this problem. Consider the problem of the minimization and maximization. Okay, so this is my f. So I can start with this again case minus del f upon del y dash is my 0. What is the partial derivative with respect to y? 2y dash minus 32y minus partial derivative with respect to y dash is a twice y dash plus 2 of y is equal to 0. If I open this bracket, 2y dash minus 32y minus 2y double dash minus 2y dash is 0. This value will be cancelled out. So 2 is also cancelled. Y double dash plus 16y is equal to 0. Fine. Now again this is a similar case. So the value of this 16, that is basically a lambda. Fine. So your solution will be a sine root lambda x. So remember always this is the case. If you compare them, lambda will be my 16. Fine. Or you can also find the value of lambda is n pi over l square. What is the l? Length is pi over 8. So that is 8n square. Fine. So anyhow, it is a sine of 4x. How you can find the value of the a? I can substitute this value y of 0. How you can find this value? I can find the value of the a by using this condition, y of pi by 2. So a will be my 1. So therefore, y is equal to sine of 4x. Fine. Otherwise, there is one more way, because we know this is the equation we have obtained. So I can solve the equation by the auxiliary equation. So your solution will be a sine 4x plus b cos 4x. Now y of 0 is equal to 0. That means b will be my 0. Y of pi by 8 is 1. That means a will be my 1. Again you will get the same solution. Now once you know the value of y, then whether it's a maxima or minima, how you can check about the maxima minima? As I told you, you have to find the second derivative, whether it's a greater than 0, minima, less than 0, maxima at this extrema. So we can find the second derivative. What is the first derivative? 2y dash plus 2y. What is the second derivative with respect to y dash? It is my 2 greater than 0. That means minimum. That means this point is my minimum. Fine. So every extremal is my maximization. Wrong. Is a minimization. Correct. There exists an extremal which is not a minima. That's a wrong, because this is true for all y. Fine. That means it is my strong minima. Fine. There exists an extremal which is not a maximal. Yes, true. This is an extremal which is not a maxima. So that means this is the minimum. A and D are my correct answer of this problem. Okay, look at this another one. Again, the solution is given to you. I can start with this partial derivative with respect to y minus partial derivative of f with respect to y dash is 0. This value will be 0. Fine. So that means what is the partial derivative with respect to y dash? It is y dash over 1 plus y dash square is 0. That means e raised to power x y dash over this value is my constant. Fine. Or I can say e raised to power x is 1 plus y dash square over y dash into twice c times of this. Clear? How you can solve that? I can find the value of, you can easily solve that. It's a c e raised to power 2x minus 1 is 1 over y dash square. So y dash will be 1 over c e raised to power 2x minus 1. Fine. Now if you integrate them, so look at the option 10. What is the derivative of this? 1 over 1 plus x square over c square. Is a plus sign, but I need a negative sign. Cancel. What is the derivative of this secant inverse? Is a x of x square minus a square, but there is no x involvement of this. So that means this option is, because there is no x, it is a e raised to power x. The solution will be secant inverse e raised to power x over c. Fine. So this all options are cancelled. No correct option of this problem. Okay, look at this another one. Again, this is independent of the y, independent of x, but it's a plus minus sign. So I can start with this equation. Can you substitute this value quickly? It's my minus 2ky minus of 2y dash 0. I can cancel that 2, y double dash plus ky is equal to 0. Again, the conditions are given to you. That means your value of the k is n pi over l. L is my pi. So that means k is my n square. And the solution will be y is equal to a sine under root of k. Under root of k will be my nx. Fine. Now, has a unique solution for all k, has at most, okay, is an integer or non-integer. Okay, firstly we can see if this is my integer. That means if root of k is integer, that means n is my integer. If n is my integer, then which of the following statement is my true? Then this number is an integer. Then what is the value of the y of sine pi? Y of, okay, first target is a. So it's a sine of n pi. Y of 0 is my 0. So a sine n pi is my 0. Fine. Now, if n is my integer, so definitely this value will be 0. So a may or may not be 0. So if this number is an integer, so that means what will happen? Will you get a unique solution? How you can say about that is a unique or not? If root is an integer, that means y is equal to 0. This is my solution. If this is solution, that is not a solution. That's a trivial solution. That's not a unique solution. If root of k is an integer, then you have an infinitely many solution. Is it true? Yes, yes, it is true, because a is my non-zero. Once a is my non-zero, this has infinitely many solution. If root k is not an integer, that means n is not integer. If n is not integer, that means this number will be my non-zero. If this number is my non-zero, that means a will be my 0. If a will be my 0, y is 0 is the only solution. That is at most one solution. That's a unique solution. And unique solution for all the cases is wrong, because for the integer case is not possible. The right answer is B and C are the correct options. Okay, look at this next one. Consider the problem. Initial condition is given to you. Check about that whether y of 1 is satisfied. This is not satisfied. Y of 1 satisfied. Y of 3 by 2 plus 1 over 2 satisfied. No extremal, unique extremal. F will be 3xy minus y square. So look at that, partial derivative with respect to y minus partial derivative with respect to y dash. So that means 3x is equal to 2y. Y is equal to 3x over 2. But this is not the right answer, because this not satisfied the given condition. So that means there is no extremal existence. The examiner has given you this because you have obtained this value, but this equation not satisfied by this given condition. So therefore, there is no extremal is the right answer. Now you can see that it's a recent year, December 2023. I will solve again the similar manner. What is the meaning of that? That's when x is equal to 1 is my 2, y of 2 is my 8. This is given to you. So let's start with this. Partial derivative with respect to y, 0, minus partial derivative with respect to y dash, 1, plus 2x cube y dash is my 0. Because what is the f? F is y dash plus x cube y dash square. So that means the derivative is a constant, 0, that means 1 plus 2x cube y dash is my constant. That means y dash is c minus 1 over 2x cube. I can take c minus 1 over 2 as another constant. So y dash is a over x cube. Fine. So can you find the value of y? I can integrate them. It will be minus a over 2x square plus constant. Fine. Again, I can take minus a over 2 as a constant. So I call finally c over x square plus d. Clear? Now I can find the value of c and d. Apply this initial condition. Y is equal to 2, c plus d. Y is equal to 8. C is equal to x c over 4 plus d. You can subtract them. It is a minus of 6. It is my 4 minus 1, 3. So c will be my minus 8. If c is equal to minus 8, d will be my plus of 10. Fine. So then what will be my solution? Solution will be, I can substitute this value. C is equal to minus 8 over x square. So now look at the option. X will be my root 2. So 3 is equal to 10 minus 8 over 2. 4 not satisfied. Root 3 is my 22 over 3. 10 minus 8 over 3. 30 minus 8. 22 satisfied. Is at 23. Cancel. 6. 10 minus 8 over 2. 4. 6. So the right answers are B and C are the correct answers. And you can see how many seconds you are needed to solve them. Again, it's a recent year, December 2023. Suppose f is defined on this case. S is any continuous function of the 0 pi. Clearly say y is equal to sine x will satisfy by this condition. Fine. So I can take y is equal to sine x. Then what is my norm of infinity? Maximum over the 0, 1. What is the maximum value of the mode sine x on the interval 0, 1? That is my 1. Fine. Add the pi by 2. That means norm of infinity at the infinity is my 1. Fine. Then on the b0, we will see whether this is norm epsilon. Epsilon is the, where is epsilon? Epsilon is any positive number. So yes, this will be satisfied because this is the 1. 1 is less than of epsilon. So this y is also satisfied by b naught. What is the norm of f naught? 1. What is the f dash? F dash means there is a y. Y dash is cos x. What is the norm of f dash at infinity? That means maximum value on the interval 0, pi of cos x. Again, it gives you the 1 value. So on the b1, what is the value? 1 plus 1, 2 is less than epsilon, satisfied. So all these values are satisfied for the function y is equal to sine x. Then I can find the value of the j0 because all the case j0. What is the j0 is? 0, that is a sine 0. So j0, that is a y is equal to 0. Y dash is also 0. It is my y is equal to 0. Y dash 0. So the answer is 0. How you can find the jy? Look at that. How you can find the value of the jy? Jy is my this case. On this case, 0 to pi, 1 minus derivative, 1 minus cos square. 1 minus cos square will be my sine square into y square, that is a sine square. Fine. So how you can integrate them? It will be my 1 minus, I can write the 1 minus cos square. So I can open them. It's a 1 plus cos 4x minus 2 cos square x. Fine. Again, I can use the orthogonal property. So let me write again here. Because it's an integration, the first value will be pi. What is the integration of this component? Minus pi by 2. Fine. It's a minus twice. It's a cos square. It's a pi over 2. What is the integration of the cos raised to power 4? So you can see cos raised to power 4 again I can written as 1 plus cos 2x over 2. Fine. So if I again use them 1 over 4, it's a cos square 2x over 4 plus 2ab cos of 2x. If you integrate them from the 0 to pi, again by using the orthogonal property, this will be my pi over 4. This number will be my pi over 2 again. And this number will be my 0. So the answer will be pi cancel out. So pi over 4 into pi over 4. That's a pi over 4 is the common into 3 over 2. That means 3 pi over 8. Fine. So now what is the conclusion is j of y is my 3 pi over 8. J of 0 is my 0. So clearly say j of y is greater than of j 0. This option cancel for the b naught because this value of the y, the sin x satisfied both the cases. So it can never be less than. So is b0 satisfied? D option cancel satisfied. C and D are my right answer. Okay, look at this another one. Again, you can see it's a recent year paper. again the one condition is imposed to you. I can find the value of the y is y dash square minus lambda times of y. So let's start with this partial derivative, minus of 2y dash. So that means twice of y double dash plus lambda is equal to 0. That means y double dash is lambda over 2. That's a constant I call as a. So it's a linear equation. So y will be my quadratic. So ax square plus, sorry, it's a linear equation. So it will be my minus ax plus b. So y will be my minus a x square over 2 plus bx plus c. Fine. Now you can apply the conditions. Y of 0 is 1. That means c is my 1. Fine. Y of 1 is equal to 6. That means minus a over 2 plus b is equal to 5. Because c is equal to 1, y is equal to 6. And integration of y is my 3. If you take them, is the integration from 0 to 1, then it will be minus a over 6, b over 2 plus c. C is my 1 is equal to 2. Clear? Now, clearly say from the equation number 1, from equation number 2, you can easily find the value of the a, you can easily find the value of b. But there is no need to find the value of a and b, because in the option they are not talking about what is the a and b. So what is the right answer of this? What is the conclusion? So your value, you can get a unique answer of a, unique answer of b, unique answer of c. That means this is the coefficient of the x square, coefficient of the x, coefficient of this. How many arbitrary constant involved? That's the cardinality. How many arbitrary constant involved in the final solution? There is no arbitrary solution obtained. That means solution is my unique. That means the right answer is A, C, B. That's a 1 is my right answer of this problem. That's why I'm asking you, there is no need to write the exact value of A and B. We obtain that, we can obtain the value, but we don't need exact value. Okay, look at this again. I can start firstly y of 0, 0 satisfied, 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 satisfied. Y of minus 1 is equal to 1 satisfied, 2 plus 1, 3 satisfied, satisfied, all satisfied. So let's start with this. 12x minus of 2y dash is equal to 0. 6x minus y double dash 0. That means y double dash is equal to 6x, which is linear equation. So that means what is the degree of the y? If second derivative is my linear, y will be my cubic. Fine. So the first option cancel, degree 4 cancel, degree 4 cancel. Right option is C is my correct answer of this problem. Fine. Always there is no need to solve them. Otherwise, if you think about that, you can integrate them. It will be my 3x square plus a. Then you can find this is a x cube plus ax plus b. You can substitute this value and obtain this. That will take a lengthy procedure, but there is no need of the condition. Okay, y is a stationary solution. Okay, solution function. Solution is already given to you, subjected to this condition. Then y is my unique, y is my polynomial, even or not. Look at that, they are not asking you about the solution. First of all, if it is an even order, you can think about any of the function which is of the even order. The easiest one is x square. Is it satisfied this condition? Yes. Satisfied this. Is it satisfied? No. Because if you integrate them, it will be my 2 over 3, which is not 1. That means even solution is not possible. What will happen if it is my odd function? You can choose any of the odd function, y is equal to x. Fine. Again, you can see this case not satisfied. Moreover, this is also not satisfied. Y is my unique. If y is unique, that means it is a polynomial. Either the polynomial of odd degree or the polynomial of the even degree. But we already discard that it can never be the polynomial of even degree as well as odd degree. That means no such value of the y exists. Okay, look at this one. Again, your f will be e raised to power, again you can see infimum and supremum. That means my target is to find, because in this case it's a u dash, whether it's a greater than 0 or less than 0. This is the case for the maximization, this is the case for the minimization. That's a supremum and infimum. So this is my case. It is independent of x and y. What is my solution? Ax plus b. Apply this condition. U of 0 is 0, that means b is equal to 0. U of 1 0, that means a is equal to 0. So my solution will be u of x is 0. On this solution I need to find the derivative. What is a u dash? It is minus 2u dash e raised to power u dash square. This is a similar question asked in the previous examination. Fine, that's a repetition. That's why there is a need of the PY quotient solution. Minus of 2 u dash square plus 4 u dash square e raised to power. Fine. At this point, what is the answer of this? If u is equal to 0, u dash is also 0. This number is my minus 2. That is less than 0. That means maximum occurs. That means supremum. Fine. Now, how you can check about what is the value of the supremum? We can also see, I can substitute this value at this point. What is the value of the I at this condition? It is my 1 to 0. U dash is 0. E raised to power 0. E raised to power 0, 1. So that means the maximum value is occurring at 1. And m is my supremum. M is my plus 1. What is the minimum value? Infimum. So since e raised to power minus of something is always be greater than 0, that means your I is always greater than equal to 0. So that means your infimum will be 0. So the first option correct, second option cancel. Now, m is attained or not? Because the maximum value I have obtained as a 1 and this is obtained at this solution. So yes, m is obtained. Can you get value of the I as a 0? I is 0 for what value of the u? So since it is my global, it is my strong maxima. So there is no weak, there is a strong maxima. So that means every times the maximum occurs. So minimum is not attained. Although infimum is my 0, but minimum is not attained. So right answer is A and C are the correct options. Now you can see it's a June 2023. It's again the recent year paper. How you can solve it quickly? You can see that this case is independent of x and y. Now in this case, y and z are my two solutions. So y will be my ax plus b, z will be cx plus d. Fine. Now I can apply the condition. Y of 0, 1, b will be my 1. Y of 1, 0. So 0, a plus b. That means a will be my minus 1. So your y will be minus x plus 1. Apply the same condition for this case. Z of 0 is equal to minus 1. D will be my minus 1. Z of 1 is equal to 2. That means C plus D. D is my minus 1. So C will be my minus 1 is a 3. So Z will be my 3x minus 1. Now look at the options. Y plus Z. If you add them, what is the value of the y plus z? It is my 2x. He said x. Fourth option cancel. Third satisfied. Look at the first option. Z plus 3y. So z plus 3y. So if you add them 3 plus 2, satisfied. 3z plus y. 9 minus 8x minus 3. 8x minus 2, but he said 2, so the right option is A and C are the correct answer. You can see that. You can see in the December 2023 1, 2, 3. 3 questions are asked. In the June 2023, we will see the first question. Now you can see the second. On this is okay. f is y dash square minus y into y dash plus xy. You can see mod of y is my positive if y is my greater than 0, minus of y if y is less than 0. This domain is for the x, not for the y. So that means this has the two choices. The first choice is y dash square minus y square y dash plus xy, that is when y is my greater than 0, and the second case is y dash square plus y square y dash plus xy when my y is less than 0. Fine. Now write the Euler equation. Firstly, partial derivative, firstly I can take as a positive case when y is positive. Fine. So it's a minus 2y y dash plus x minus partial derivative of 2y dash minus y square is 0. Open this bracket, minus 2y y dash plus x minus 2y double dash plus 2y y double dash y dash is 0. So that means y double dash is x over 2. Fine. If you look for this case, then what will happen? This number is my positive. Fine. This number is positive. Again, it will be cancelled. So in the both the cases, you will get the same answer. Then, how you can find the solution? I can integrate them. Fine. So it is x square upon 4 plus a. Then it is x cube over 12 plus ax plus b. Fine. Now you can substitute these options. Y of 0 is 0. B will be 0. Y of 1 0. That means 1 over 12 plus a is equal to 0. So my solution is x cube. A is my minus 12 over this. Fine. So clearly say y is equal to 0 is the only extremal. That's the wrong answer. It has no stationary tensor. There is no arbitrary constant involved. So that means this is my unique solution. Is a unique extremal, not identically 0. Yes. Infinitely many, wrong, because it is a unique solution. The right answer is C is the correct option. So you can see that in the June 2023, one second and one more question appear in this case. Again, it's a very simple y square minus 4 y dash plus 4 y dash square. So I can apply the Euler equation. Partial derivative with respect to y, 2y minus 4, partial derivative with respect to y dash, minus 4 plus 8y dash is 0. So if you open them, 2y minus 4y dash plus 4y dash, 8y double dash is 0. So that means y double dash is my y over 4. Fine. So how you can find the solution? Or I can say 4 y double dash minus y is equal to 0. So auxiliary equation will be 4m square minus 1 0. So my solution is C1 e raised to power x over 2, C2 e raised to power minus x over 2. Fine. Once you get the solution, so now let's see, the initial condition is y of 0 is 1. So that means C1 plus C2 is, sorry, y of 0 is 1. So this case, and y dash 0. What is the y dash 0? Is C1 over 2 minus C2 over 2 is my half. So from this case, we can say C1 plus C2 is equal to 1. From this case, we can say C1 minus C2 is equal to 1. So what is the right answer of this? C2 will be 0, C1 will be 1. So my right answer is y is equal to e raised to power x over 2. Fine. Now look at the option. Let me clear. Y is a convex. What is the meaning of the convex? Second derivative must be greater than 0. Then it is my convex. So what is the second derivative of this? 1 over 4 e raised to power x over 2. So clearly say x exponential is always greater than 0. So yes, it's a convex. Concave when y double dash is less than 0, but it is not concave. Y of x plus y. What is the value of the x1 plus x2? It is e raised to power x1 plus x2 over 2. I can return this number is x1 over 2 into x2 over 2. This is y of x1, y of x2. Y of x1 into x2. This is e of x1, x2 over 2, which is not equal to y of x1 plus y of x2. So the right options are A and C are my correct answer of this problem. You can see 3 questions are asking in the June 2023, 3 questions asking in the December 2023. All I have explained you in a very simple manner. Don't forget to like and comment on my video. Okay, this is again a very simple question. This is u dash. So you can start with this u minus partial derivative f of u dash is equal to 0. Fine. Now they are talking about the infimum. So what is that? You have to check about u dash square, whether it's a less than 0 or greater than 0. Fine. So you can solve this equation, get the value of the u. Fine. And then you can find the second derivative, check whether it's a less than 0 or greater than 0. So firstly I can see that the second derivative will be my 2, which is always greater than 0. Fine. So I will give you this exercise for you. You can solve this question by yourself and let me know your answer in the comment box. Which one is the right answer, whether A, B, C or D, so that I can understand it, whether you are able to understand this lecture in a very simple manner or not. So this is the way you can solve each question in a simple manner. I will upload the part 2 again if I get a good response of this video. So we will see the next lecture very soon based on your comments and like. I hope you can share this video with your friends. Best of luck students. Happy luck.